familiar faces here joining us on Zoom, and very honored to have been asked to give this set of classes, 2 Zoom classes and an in-person lunch and learn on things that I've learned in my spiritual journey as a scientist. I was asked to introduce myself, so I will do that before I go into the formal presentation. Seeing so many familiar faces, it feels odd to introduce myself, but not every face on the screen is familiar, so maybe it makes sense. So I am a recently retired physics professor at Syracuse University. Now my title is a professor emeritus at Syracuse. I came to Syracuse to take up my position in the physics department at SU in 1991. And my research was on the development of a new kind of telescope to look for black holes. And after decades of work, it succeeded really spectacularly. And the leaders of the team won the Nobel Prize for what we did, finding black holes that collided with one another. So my arrival in Syracuse and my starting at Syracuse University was 1991. People here on the Zoom call probably are more likely to know me from having been a member for many years at CBSCS. One of the high points for sure of my time in Syracuse. Sarah, my wife Sarah, and I joined in 2006. And I'm mentioning those dates because there's something interesting between those 2 dates. We came to SU in 1991, joined CBSCS in 2006, and it wasn't that we had joined another synagogue when we arrived and then switched over. I had went on a spiritual journey and returned to the Jewish roots I'd left behind the day after my bar mitzvah. And in a real way, what I'm going to be sharing with you all tonight, and then at the second lecture in May, and then at the Lunch and Learn, is a version of the spiritual journey that I went on. That is what led me to re-affiliate with organized Judaism, join CBSCS, and become active in the wonderful community that is CBSCS. So I'll just say a bit more about the outlines of that journey. The content of it will emerge perhaps indirectly, but with this tip-off, maybe you'll see it happening in the lectures themselves. But the proximate cause of my change in attitude of all science all the time to trying to combine science with religion came while on a business trip, and I was killing time. I went to a bookstore. It was the Christmas season, so the Barnes & Noble was filled with Christmas-themed books, and one tiny table had Jewish-themed items because they didn't want to make Jewish customers feel sad. And I saw on this table a book. I think I have it right here, yes. Commentary on the Torah by Richard Elliott Friedman. And this book just sort of conceptually jumped off the table into my eyes. And I said, oh my goodness, I've read all the great classics, or almost all the great classics, but here I was considering myself at least a lapsed Jew, never having sat down and opened the Chumash and started reading from Bereshit Aleph on to the end of Devarim. That's terrible. I should just, for my own cultural completeness, read this great work of human literature. So I bought it, went back to my hotel room, and was utterly fascinated. Not so much because it told a story that was more convincing than the scientific view of the world that I had been living with for my whole adult life, but just because it's a truly fascinating book to read. So much so that I kept reading it, rereading it, and then I realized reading it over and over again, I still wouldn't understand it. It's too weird, too confusing. Don't think I'm telling anyone on this call anything you don't know. So I looked for help in understanding this strange but evocative text that is our Torah. And I came across the writings of Abraham Joshua Heschel. And ever since I started reading Heschel, first his book, God in Search of Man, and then anything else by him that I could get my hands on, I felt like I was in the hands of a guide who was explaining things in a way that, although I didn't understand it at first, I thought was directed at my questions. So what I'm going to be sharing with you is looking back over the past 20 years, I think it's been, since that evening in a Barnes and Noble in Baton Rouge, Louisiana, what I think I've learned and why I think with Heschel's help and the help of the rest of our sacred texts, why I think that Jewish commitment is 100% harmonious with science. Not only that, but that it is in fact a richer and more true view of the world to try to see science and Jewish religion in particular at the same time. So that's my overall theme for these three classes that we'll share together. So I'm going to bring up a PowerPoint for this evening, and I hope you all can see a PowerPoint title slide. If you do, can you raise a thumb or something like that? Yes. Okay. I see Lois's hand and Mark's hand. All righty. That's great. So I've organized my thoughts into three classes. We'll have two via Zoom, one tonight, one in May, and then the Lunch and Learn together in June. And tonight, what I'd like to do is talk about a topic that confronts head on the two, if I may call them, somewhat competing worldviews, or worldviews that at least most of us think most of the time are in tension: scientific worldview of modernity, religious worldview. And tonight I'm framing that question, potential conflict or potential dialogue, around the topic of determinism versus human choice. And if there's any technical terms in that title, I will explain them very shortly. I won't be able to check the chat while I'm going through this PowerPoint, but if anyone wants to interrupt and ask a question, if you use the raise hand feature in Zoom, I should see you trying to get my attention, and I'll be happy to take the question. And there'll surely be time for questions at the end. So, so another way of framing this issue as a question is the title on this second slide of mine: can everything about you be explained as if you were only a very complicated machine? That's my topic question. And to frame it visually, I found an image of one of my favorite toys from my boyhood, Mr. Machine. I don't know if anyone else who's here on Zoom with me tonight played with that toy, but I thought it was really spectacular, with this big wind-up handle on the back and a spring and gears. And when you wound it up and let it go, it walked like it was kind of a little person, except it wasn't. You could look through the clear plastic frame and see the gear work happening. So that symbolizes one idea, and this image of kids playing in the sunset represents the opposite extreme idea of that the joy of being a human being has little or nothing to do with our material makeup. And so with those two extremes in mind, I want to explore how these two potentially opposite pictures of human existence interact with each other, how you can choose which direction you lean to as you understand the world. And of course, I'll be sharing my ideas as well. And so to confront this question, I've got two brief quotes from two of my favorite religious thinkers. One, obviously, would be the Jewish theologian, the great Jewish theologian of the 20th century, Abraham Joshua Heschel. And he framed this exact question in these much more poetic words. He wrote, "What am I? A massive protoplasm, a complicated robot, a tool-making animal? Am I anything more than just a physical being?" He framed it as a question, but I think it was a rhetorical question that we'll take as a suggestion of where he might come down. Perhaps surprisingly, my second favorite religious thinker is not Jewish at all. It's Marilynne Robinson. She's very much an out Calvinist Protestant. She's most famous, I think, as a Pulitzer Prize-winning novelist. She wrote Housekeeping, Gilead, Home, Lila, Jack. I actually am a bigger admirer of her several books of essays. And if anyone wants links to them and you have trouble typing your name into Amazon and finding the list, just get in touch with me and I'll direct you to some of my favorite books of hers. But here's a wonderful quote from one of her essays where she says, "It's an error of much scientific thinking to exclude much that we do know about the vast fabric and the fine grain of the cosmos." And in case it's not obvious, when she worries that much scientific thinking excludes much that we do know, she is pointing to the tendency of at least some outspoken atheist thinkers to try to tell their listeners that whatever we can't explain by the laws of physics about human beings, we'll get it really soon, that you are, for all intents and purposes, a very complicated mechanism. And she's quite clear here that she's arguing against that point of view. So another way to frame this issue is the following. It is surely the case that, however you come down on this major question, that much of who we are is related to the structure and function of our brains. And neuroscience is revealing more and more of that all the time. But the question isn't so much, are we somehow related, is our human identity somehow related to our brains? The question is really, is everything about us determined by the laws of nature as applied to this physical system, this few pound hunk of meat in our skulls that is our brains? Or is there any room for something that, for lack of a better term, we would call free human agency? So what I'll do in the rest of our time together tonight is make sure that everyone is on the page of, when I say the word determinism, that you know what I'm talking about. So I'll get a definition, a working definition of determinism, but here's the hint. It's the claim that you are, for real purposes, just a machine. And then we'll look at why someone might be tempted to even say that, but then ask the question, could it possibly really be true? And I will be arguing that no, determinism can't be true. But there's a near cousin of determinism that goes by the name of naturalism, which can't be refuted anywhere near as easily, and which I think is the real competitor of religious thinking today. So after we dispose of determinism, we'll grapple with naturalism as the alternative that can't be refuted so easily and is maybe almost as interesting as determinism seemed to be. But then I will point out why not only I suspect that naturalism is way too narrow a point of view, but I will try to convince you all that, for most of you at least, naturalism as commonly formulated doesn't really give us a complete enough description of what it means to be a living human being. But we'll see. We'll see how well I do in convincing you. Okay, so that's where we're going to head. And I'll get right to how I'm going to argue against first determinism, but also against classic naturalism as well. The issue, as I see it, is that to be a human being is to be someone who has the capability for creativity, for moral reasoning, and moral action, whether we live up to that capability all the time or not, or even more specifically, a kind of being there, which on the slide I've described as being able to say I and you. And these are things that don't map onto the kind of physics-inspired description of the world that I spent my working hours working on, and a tip-off that this is going to be challenging for any kind of too rigid scientific view of the world is that creativity, morality involve aiming at some future goal. I want to make this original thing. I want to make this beautiful thing. I want to do the good thing and achieve something in the future that doesn't exist yet. And why is that at odds with the scientific worldview? Well, as a physicist in my day job, I felt like I was helping the cause of learning the laws of nature. And when we, physicists or physics-inspired scientists, were formulating, proposing new laws of nature, testing those laws of nature, seeing whether they worked or not, we were always working in a framework where we realize that what laws of nature do is they predict the future based on the state of the universe in the past. And first of all, future goals play no role in that because you can't say in this physics-inspired point of view, oh, I really wish that this new piece of music that I can kind of hear in my head, that I can bring it into being. It's either it's all there ready to happen, just letting the laws of nature let your hand move across the page and write that music, or not. And you're aspiring to it plays no role in whether that new piece of music, for example, is going to be created by you. It's all a playing out of how the universe used to be. So if we think that we ever do something goal-oriented, try to do the right thing, try to create a beautiful thing, and we think there's some suspense and that our efforts make a difference, then we are actually in tension with this idea of that we are just all explainable as if we are machines. So yet another formulation of the question I'm posing for us all tonight is, can goals be real features of the world? Or is the world simply or complicatedly, but still essentially a playing out of how the world already was in the past. So I'm going to do, before I make my strongest argument, I want to see if together on this Zoom call, we can do a little poll in real time. I'm going to propose that 5 different ways of thinking about the world that might include in that list of 5 different ways of thinking about the world, one that matches your own belief, at least before you've had a chance to listen to my whole talk tonight. And then I'll ask people to choose which one best describes your point of view, and we'll see where we stand before I make my strongest case. So here is a list where I tried to encompass a range of different points of view on now framing the question, do I have free will separate from the working out of the laws of nature on my material being? So perhaps you believe more or less my statement number 1, which is my body does stuff and that's all that there is to me. Or maybe number 2 seems more like what you think. I seem to make choices, but I'm at the mercy of hidden urges beyond my control. Or maybe you believe I try to do what I want to do, but I often don't succeed. Or perhaps number 4 best describes how your life seems to you. Although I often struggle, I'm usually able to do what I hope to do. Or maybe you are in category 5. I'm able to figure out what I ought to do and almost always succeed in doing it. So if you can, think about these for a moment. And if you see one of them that best matches your own view of how you navigate the world, where you are on the determinism to free will spectrum, if you would type a number from 1 to 5 in the chat, and I will be able to do a quickie non-scientific poll of where people stand. And I promise not to pay much attention to the name that goes with the number from 1 to 5 in the chat. Just want to see it happen. Okay, I'm already seeing a bunch of them. So let's see. All right. All right, I'm seeing 4 and a 4 and a 5 and a 5 and a 4 and a 4 and a 4 and a 4 and a 4, 5, 5, 3. Okay, people who hesitated are more towards the low numbers. The people who jumped in were there. Oh, here's someone who has 4 and also 1. All right. What an interesting set of numbers. You can, if you haven't typed yet and you want to, I will look, but I've already seen enough to give me a sense of the room. With the exception of the one person who typed 4 and also 1, I didn't see any 1s at all. Seen a lot of 3s, a lot of 4s, a few 5s. So maybe I've set myself up to succeed by my precursor remarks, but I think this is mainly a group who is already predisposed to be skeptical of the determinist point of view. So in a way that makes me happy, but I hope you will be patient as I drive a stake into the heart of determinism, but then try to revive it with its cousin naturalism, and then maybe we'll have a fairer idea of how to think about the world. So let's see. Oopsie. All right. So we had almost no 1s. So only people who are willing to answer 1 are really determinists. So everyone else is skeptical of determinism and has some feeling for free will. So I feel like I'm in a bunch of kindred spirits. So if you get no other value out of this talk tonight, you'll at least, I hope, get some backup for your pre-existing suspicion that you weren't ever a determinist. So let's go. And so I'll talk about how the idea of determinism first emerged. And it emerged out of the
Excuse me,
early
Peter.
development. Yes.
Peter, could you delineate a little more clearly the difference between determinism and naturalism and where the boundary lies?
That's such an excellent question, Mark, that I am going to defer answering it for about 15 or 20 minutes, but then I will give it as full an answer as I possibly can. So if we get almost to the end of the talk and you haven't heard a clear enough answer, will you ask again?
I will do that.
Okay, thanks. Yeah. First, we have to drive a stake into the heart of determinism before we can come to naturalism. So the idea that laws of nature govern the world comes from the very beginnings of modern science. And physicists like to date that, at least some of us, some of the time, to Isaac Newton's great book, the Principia Mathematica, which came out in 1687. Of course, he had outstanding predecessors like my hero Galileo earlier in the 17th century, but this is where it really emerges. And everyone is familiar with the likely apocryphal story that Newton was confused until one day, to rest from his confusion, he sat down under an apple tree, and when he saw an apple fall to the ground, suddenly it hit him. It probably worked harder and had less instant insight than that, but it's a nice story, and it incorporates at least some of the truth. But let me tell you the story as I would teach it back in the day when I was teaching introductory physics at SU. So you can boil down Isaac Newton's most important insight about how the world works to one equation that is so simple it takes 1, 2, 3, 4, 5 characters to write. Now, of course, any universal law of nature that you can write in so few characters is so profound that you need to spend years learning how to interpret it. And we don't have years together, but I think I can explain the gist of this idea in just a minute or two. This is Newton's second law. You may have learned it in school, and if you learned it in school, you probably saw it as F equals ma, which I think is a ridiculous organization of his profound thought. I prefer to do the tiniest bit of algebra and write it as A equals F over M, because, as my friend Mark, I know we've got at least one mathematician here, knows that equations are sentences, and the style of sentence that, if you want to understand an idea, is best is to say, the thing I put on the left-hand side of the equal sign is the mysterious thing I would like to know, and I'm going to explain it in terms of what I put on the right-hand side of the equal sign. At least that's the syntax that physicists use when they pretend to be mathematics and they write equations. So I'm using that style here. What Newton taught the world was that an object wants to either stay at rest if it is at rest, or if it's moving, keep moving at precisely the speed that it has and precisely the direction of motion that it has, unless something disturbs it. And the disturbance that can cause an object to change its state of motion is a force. And in this very compressed equation, A is standing in for the word acceleration, which means change in speed, speeding up or slowing down, or change in direction of motion. That's what we call an acceleration. And A equals F over M says any acceleration, any change in the state of an object's motion is caused by what's on the right-hand side of the equal sign, a force. And to get the numbers to work out and the units to work out, we have to divide whatever force is applied to an object by this characteristic number appropriate to the object in question, namely its mass. So if we know that a force has been applied to an object and we know its mass, we know there's going to be a change in the state of its motion given by that force divided by the mass. Now, if you know enough to want to ask this question, I will just anticipate it for you. Motion is something, because it has speed and direction, I should be making clear with my symbols that mathematically speaking, it's a vector, and that acceleration and forces are vectors. If that helps you relax about the fact that I actually knew what I was doing when I was teaching physics, that's good. If the word vector doesn't mean anything to you, don't worry about it. It's all in the words I put on the slides. A force can change an object's speed of motion or direction of motion. And in fact, this is the fundamental insight that lets us understand how things work. And Newton knew that that apple fell from a tree for a reason. He also knew that if you shot a cannonball out of a cannon, he could predict how high it would go and then how far downrange it would go. And he could predict how those numbers would change, its height and its range, depending on the angle that the cannon barrel was aimed at, how, what was the speed of the cannonball as it left the barrel of the cannon. He could do all of that using exactly the same law as described the falling of an apple. Furthermore, he knew that exactly the same law also applied to how far something would move around the earth if you stood on a tall tower and threw it horizontally. Depending on whether you threw it at a small speed, a medium speed, or a high speed, it might go just a little bit beyond the base of the tower. It might go far, or with enough speed, it would go so far that it would orbit the earth and never fall down. So Newton was thrilled by this because he found a universal way of describing seemingly disparate phenomena. The fall of a simple object, what would happen if you threw an object either with your arm or with a cannon or whatever. And in fact, he realized that because he could describe orbital motion, that the same law was also accounting for the motion of the moon around the earth, of the earth around the sun, of all the planets around the sun, all of them different examples of one phenomenon, motion under the action of a force. In the case of all of those, gravitational force. And this was incredibly powerful. I mean, the world had been turned upside down, first by Copernicus, then Kepler, then Galileo, by trying to figure out what were these objects moving around in the sky called the planets. And was the sun a planet that orbited the earth as the ancients thought, or was the earth a planet that orbited the sun along with the other planets as Copernicus, Kepler, and Galileo believed? And Newton nailed the question. He was able to show that with his simple rules, you could see all of what was going on as a simple playing out of A equals F over M, where F was the force of gravity. And it was wonderful, and it worked so well and so predictably and so reliably that people came to be thinking of the solar system, and by extension, everything else in the universe, as if it were a clockwork, a simple machine, kind of like that Mr. Machine toy that I was so delighted by as a kid. And on this slide, I've got a picture of a clockwork model of the solar system. And clockwork models of the solar system used to be, the status toy, that if you were really rich and you really wanted to impress your friends, you arranged to have someone make for you the most elaborate, accurate clockwork model of the solar system. So this orrery is from about a century after Newton, from about 1780. I think it's gorgeous. The planets are the little spheres on the sticks, up at the top of the sticks, at the top of the orrery. But half of the fun is seeing all the gears that make it work, that make the planets move around the sun at the center there at the appropriate speeds to appropriately match how the real solar system is going. So at one level, this was a status symbol or a toy, but at another level, it was actually an expression in metal of a philosophical worldview that said, things are material things. They behave according to the laws of nature that Newton taught us. And Newton taught us that the way those things work is, all right, you know how things are moving and you know the forces, then the forces tell you how motion changes, and you just play that procedure forward and you can predict what's going to happen in the future, in principle, as far into the future as you want. And this was, needless to say, a revolutionary change in how people thought about how the world worked. And there's I think, an apocryphal story, but it's so good that it ought to be true, about an encounter in 1802 between the Emperor Napoleon, who was in charge of not only France, but a huge portion of Europe. And he visited one of the greatest physicists of France of that era, the astrophysicist Pierre-Simon Laplace. And we know that this encounter took place. We don't have the dialogue, but it's been reconstructed retrospectively for us. So if Napoleon and Laplace didn't say exactly these words, they ought to have. So here is Napoleon complimenting Laplace on a book that he's just published. He says, "You've written this huge book on the system of the world, that is, on how the solar system works, without once mentioning the author of the universe." And Laplace is supposed to have replied, "Sire, I had no need of that hypothesis." And this is a fabulously pregnant dialogue. And let's try to pull it apart, see what it was taken to mean. It could mean something as simple as when Laplace was doing his astrophysics job of trying to predict where planets would be in the future, that all he needed to do was know where the planets were right now and how fast they were moving and Newton's laws, and then that sufficed for knowing the motion of the planets around the sun into the future. But a more maximalist interpretation has attached itself to, "Sire, I had no need of that hypothesis." The maximal interpretation wasn't just that this applied to the solar system, but that it applied to any material object whatsoever, okay? And furthermore, that, because we're material objects, that everything, including all of us, all of our motions, our actions, our thoughts, everywhere and for all time could be accounted for. So if this maximal interpretation were true, the Newtonian worldview seemed to be saying that there's nothing left to be understood about anything in the universe, including human life. Because after all, here's why it makes sense, and I'm making scoffing quotes because in the end, I don't believe it makes sense, but here's why a sensible person might be tempted to think this idea. So our bodies are made up of matter. We are made up of small material things called atoms. It's a lot of them, okay, but let's put that aside for the moment. And so in principle, why shouldn't we able to apply Newton's paradigm that Laplace defended to Napoleon? Namely, there's a bunch of things. We should be able to know where they are, how they're moving, what the forces are on them, apply Newton's law, A equals F over M, to each one of those parts, and we should predict, therefore, where those parts are later, and we could apply the same procedure again and again and predict where all our atoms go on into the future forever. And if that were so, and if our bodies, including our brains, are ourselves, then why shouldn't we take that to mean that what we do, who we are in fact determined by the laws of nature? That's the maximal hypothesis that Laplace might have been putting forward. In other words, he was posing the question, are you just a machine? And in this reading of how his dialogue went with Napoleon, he might have been asserting that even something as complicated as a human brain in which is instantiated a human mind is at base simply a clockwork and therefore determined by the laws of nature applied to where the system was at some time in the past. But let's try to think harder about what Laplace could have been saying and whether it could possibly be true. So, could he have really been asserting that Newton's law predict the future precisely? Newton's laws, mathematically speaking, would predict the future precisely of some object, figure out where it is, where it, and how it's going to move for all time. If we were able to know precisely the forces on each object in question in the universe due to every other object, and if we also knew the position and velocity of everything in the universe at some specified time, if we knew all those things, all the forces between objects, and if we knew where everything was and how they were moving at some particular time, and if we knew that precisely, then the laws that Newton taught us and that Laplace defended to Napoleon would in fact be predicting everything, and therefore determinism would be true. But could Laplace have been right even about the solar system? That was in fact what he and Napoleon were talking about in particular, Laplace's new book on the solar system. And even for the case of the solar system, as we now know, looking back with hindsight of a couple of centuries trying to do this problem, it doesn't even work for the solar system. And here's why. The solar system contains a sun, 8 planets. I used to say 9. Now we've demoted Pluto to a minor planet. Okay, we got a sun, 8 planets. Those planets have over 200 moons. But even more interestingly, there's over 600,000 minor planets. Most of them are asteroids, comets, there's things like Pluto, and so on. And even with all of the computing power that we have today, making precise predictions of where the various planets are arbitrarily far into the future is really hard. It takes the biggest computers that we have, and here this is probably no longer the biggest supercomputer around, but it illustrates the idea. Even with the most powerful computers that we have, the problem is intractable. that you can get pretty good results. All of us who witnessed the eclipse happening just on time on Monday realize that these predictions are not bad, but if you really want to know with great precision and arbitrarily far into the future where everything in the solar system is going to be, it's an almost impossible problem, because there's too many things you have to know to too great a precision. So that's weakness number one with the determinist program. It's practically impossible to carry out, even for something as simple as the solar system, because the solar system is not simple enough. But there's other difficulties with the determinist program as well. Newton knew a lot of physics, taught us a lot of physics, but he surely didn't exhaust everything about the laws of nature that we've come to know in the succeeding centuries. And we know at least three things that Newton didn't that make the problem much harder. There's this idea of chaos, which means that that those equations that Newton and Laplace were so proud of are fiendishly difficult to predict arbitrarily far into the future. They require so much more precision than anyone would have guessed to make the precision, the predictions. There's also the fact that Newton really didn't have the laws of motion exactly right. There's the idea we learned from Einstein of relativity, and the idea that Einstein argued against most of his life, but lost the battle on, that the rules of either Newton's laws or Einstein's relativity have to be modified to be consistent with the formulation of laws of nature known as quantum mechanics. All three of those things make the problem much harder. Even further, we know that there's laws of nature that we don't understand. We know that there's forces that that we don't yet have good laws for. We know there's kinds of material, dark matter or dark energy, whose properties we still don't understand. And the notion that you could apply Laplace's version of the Newtonian paradigm and determine the future based on the past has come to seem kind of more ridiculous with every passing decade. And I'll just mention two things that make me convinced that no physicist should stay with a straight face. Well, we understand things now and we only have to calculate things forward. There's two things about reality that I want to mention to shake anybody's overconfidence that physicists have it almost entirely understood. One of them is this very bizarre idea that comes from quantum mechanics called quantum entanglement. And it's respectable enough that the Nobel Prize in Physics in 2022 was given for an experimental proof that entanglement happens. It's a long story. I couldn't even in 1 hour explain everything about entanglement, but in one sentence, I can say that the key idea is that things across the universe are linked in ways that defy any simple kind of intuition we have about the structure of space and time. And in particular, it defies the idea that if something is going to influence something else, it should communicate with it by bumping into it or applying a force right there at it. Things that are completely far across the universe from one another under some circumstances can influence each other in this bizarre way called entanglement. There's another thing I just want to mention, and if you want to ask more about it in the question time, then you're welcome to. Something else about reality that's astonishing. And that has to do with the nature of time. The way time feels to us as one moment that we wait to pass to be succeeded by another moment and another and so on isn't really how time works as far as physics shows us. The only way we can make sense with the laws of physics that we know is if we have a world picture that says there's nothing like a moment to which we can apply the word now, at which everything is existing, that's distinct in any way from any other time in the history of the universe. The only way physics, as taught to us by Einstein in the theory of relativity, can make sense of how the world works is to say that every moment of time in the entire history of the universe is equally real. There's no way to pick out a particular moment to dignify with the word now. That's me speaking as a physicist. Me speaking as a human being says, all right, I got to look at my watch to see if I'm keeping to schedule so that I don't keep people up too late. And I'm really worried and I don't know how it's going to come out, and we'll have to wait and see. And hopefully I'll finish the talk on time, but slowly enough so that it's clear. Okay. So I live in a moment where now means a lot. But when I do my work as a physicist, I can't make sense of the word using the concept of now. I'm only bringing this up to suggest that anyone who thinks physics is almost there and that we really got the list of everything that's going to enable us to carry out the Laplacian program of put in all the laws of nature, put in where everything is, put in the list of forces, turn a giant crank, and we'll predict the future, is not taking account of how much we don't know and how hard the problem is. So the lesson that I draw from this is that these limits of physics, the difficulty of the calculation, the huge list of things we don't know, tell me that no, we cannot treat a complicated system like our brains as a clockwork, let alone, since we can't even do it for what this clockwork orrery model of the universe, of the solar system, was attempting to show. And let me try to really drive the last nail into that coffin. Let's say I didn't convince you yet, and you wanted to say, no, I really want to, I want to invest in some supercomputers or maybe a quantum computer, and I really want to try to carry this out because it would be so amazing to predict what you think and what question you're going to ask me at the end of the talk. And that would be really fun if I could do that, right? So what if I were arrogant enough to think that maybe I could pull this off and predict those questions? What would be involved in my having to do it? And here are some facts that I've learned about a human brain that are relevant to the question. A typical human brain contains about 100 billion neurons. And neurons, that's the name for the cells that make up your brain. It also contains, in an essential way, not 100 billion, but 100 trillion synapses. Those are the connections between neurons. And it's that wiring diagram of one neuron to another through various synapses that we think contains the logic that's embodied in your brain and has something to do with how you think. But when you start to think of it as something that has a wiring diagram, you realize not only are these numbers huge, but we don't know what the wiring diagram is. There doesn't seem to be any prospect of ever knowing the complete wiring diagram. 100 trillion connections between 100 billion brain cells. And even if we did at some moment, we also know that that wiring diagram is constantly changing. And furthermore, we really don't know the laws that govern signals transmitted from one neuron to another, nor do we know the laws that cause the formation of these connections called synapses. The word on the slide, synaptogenesis, is too big a word, but I saw it and felt I wanted to use it. It looks so cool. But basically what it means is the brain is a dynamic thing. And We can't just explain the brain as it is in a snapshot, but how it should change itself over time. Really hard. Because these numbers, in case it's not obvious that 100 billion is a large number, let me describe a few other things that are characterized by the number 100 billion. I said a moment ago, it's the number of neurons in a human brain. It's also the number of stars in the Milky Way galaxy, one of the bigger things we know of in the universe. It's also the number of galaxies in the observable portion of the universe. Your brain, okay, is an astronomical object. The numbers involved are truly, literally astronomical. But worse than that, for the case for determinism, the brain is really hyper-astronomical. The number 100 trillion that describes the number of connections between various neurons in a brain, I don't know any astronomical system where you need a number that big to describe it. It's the largest useful number I know to describe anything in the universe. In your brain, okay? So each of us occupies the most complex kind of object in the known universe. And it's impossible even to conceive of a complete description, let alone understanding of a human brain. So it's unimaginably beyond the reach of a completely detailed calculation. And therefore, at least the maximal interpretation of what Laplace was saying to Napoleon, that, oh, I don't need anything other than the laws of nature, it's really hard to see how you could carry out a program to prove that that was true. And this does nothing to take away any of the dignity of all of the interesting work that neuroscientists are doing, but it will never be complete enough to actually turn a giant crank, make a calculation, and predict what someone is going to think. So determinism is dead. There's just no way it can possibly work. But now I'm finally going to answer Mark's question about naturalism. As determinism dies, another idea pops into many people's heads. And the idea is, okay, you've convinced me that no one could literally predict with a giant computer all your thoughts and all your actions. No one could carry out the calculation that Newton proposed and that Laplace proposed. But maybe we don't need ever to be actually able to do the calculation. Maybe we just need reason to believe that in principle one could do it, so long as one had a hypergiant computer and had precise knowledge of everything. Couldn't we treat the brain as if it were a machine in principle? And this is the idea behind the concept called naturalism. Naturalism is a term that describes the idea that I think occurs to most of us one time or another. Most of us, if you asked what is out there, might agree with a sentence that said, nature is all there is. And if nature is all there is, doesn't this tell us enough to know what the world has in it, what it doesn't, and at least the most important things of how it behaves? The trouble is, there's actually many flavors of naturalism. And on this slide, I'm reinterpreting what you might mean if you agree with the statement, nature is all there is. You might mean, we are just machines made out of atoms, get used to it. Or you might mean, there's nothing spooky in the world, but nature is a pretty amazing thing, so rich that it's really remarkable and we'll never get a 100% handle on it. Or you might mean that nature is so astonishing that we really need to expand our concept of what nature is beyond the mechanical paradigm of material objects in motion. One version or another of this has been labeled naturalism by many thinkers. And the reason I'm laying out this range of ideas is that the strictest version up at the top, where basically atoms put together to make machines, that still includes the idea that the past determines everything about the future. Whereas if you move down the list of possible interpretations of what the word naturalism means, you can easily call yourself a naturalist if you live down at the bottom of the slide and still believe that, no, the past hasn't determined everything about the future. We can create a wonderful future. And I want to put just one other scale on the same list of different concepts that go by the name of naturalism. At the top goes something that, if someone is proud to hold that idea, they might call it strict naturalism. And if you want to call yourself a naturalist, but you really believe that I want to expand, we need to expand our concept of what nature contains beyond material objects moving under laws of nature, that goes under the name of expansive naturalism. And I may use either of those two terms in the next few slides. In fact, I plan to. So the reason this matters and the reason that spectrum is an important thing to keep in mind when someone tells you, oh, I'm a naturalist, is that if that person who says I'm a naturalist is really a strict naturalist, strict naturalism is basically a way that people use to list a long list of things to not believe in. And so strict naturalism is generally taken to affirm that one does not believe in the supernatural, or God, or the soul, or a non-material mind, or free will. Now, you might hate one or two of those things, but given the answers to my quiz at the beginning of the talk, I think that most people who are here together on Zoom don't want to give up at least free will, and maybe some of those other things higher up the list are things you might not want to give up on either. So maybe you're a naturalist, but not a strict one. So when I take the lesson from physics and the other sciences and the fact that they are far from complete, I take the lesson to be that just as determinism is impossible for computational reasons, there's actually no scientific basis for that strictest form of naturalism, not if we want to imagine that we have some power to choose how to create, to choose how to behave, to choose our future and act to try to make that future happen. So there's no scientific basis, I claim, for the strictest form of naturalism, and that's even before we include the question of who we are and what values we have. Because now I want to just assert, and for the rest of the remaining few minutes in my talk, I'm going to be speaking in my own voice most clearly. Seems to me that ourselves and our values are parts of nature. We've got this sense of being here. Interiority is a multisyllabic word for this sense of I am present in the world, thinking about it, acting in it. We participate in the world. We listen, we see, we think, we move our hand, we type up PowerPoint slides to present to CBSCS. And interiority, participation, and goals that we choose and that we judge according to our values are, in my humble opinion, informed by Abraham Joshua Heschel, as real as the material parts of the universe. And Heschel had a special term for these. He called this aspect of existence the ineffable, ineffable being a polysyllabic word for what can't be described easily in words. And the challenge that Heschel taught me to lay down to the naturalistic worldview, at least the strictly naturalistic worldview, can be explained in a list of questions. Can strict naturalists believe in the correctness of justice? And here's a picture of Heschel with King at the March from Selma to Montgomery. Can strict naturalists believe not only in the correctness of justice, but in the reality of love? Can strict naturalists believe in the requiredness of compassion? Can strict naturalists believe in the reality of goodness? Can strict naturalists believe in the validity of truth or in the compellingness of beauty? And my friend and idol Marilyn Robinson says a wonderful thing about the reality of beauty. She says, if through our minds and senses we participate in absolute reality, then beauty is an active element in creation. Beauty is a conversation between humankind and reality, and we are an essential part of it. And Heschel, to make the point as clearly as he could, said this wonderful thing, that free will is really the domain in which we live out our values, or in Heschel's words, the opposite of free will is not determinism, it's hardness of heart. So to wrap up, let me say that I've become convinced that naturalism can be true only if nature is expanded enough to include not only the material aspects of our being, but actual human agency, which is to say, nature must be made of more kinds of things than atoms. And so I'll ask you to choose for yourself, and this time I won't ask you to vote, which would be the bumper sticker you would most like to have on your car. Would you like to have on the bumper sticker in your car that said, stuff happens? Or would you rather have the bumper sticker that says, practice random kindness and senseless acts of beauty? So that's my prepared talk, and I would love to take questions from you all. And let me get out of this, and maybe if I stop sharing my screen, I can start to see hands. Okay, so Jacob has raised his hand. So Jacob, why don't you unmute yourself and ask your question? Other people find your raise hand feature and get in line behind them if you want. Go ahead, Jacob.
Hi, everyone. So I know I missed like the first 10 minutes or so of your talk. I assume that's when you introduced the motif of the machine man toy thing, right?
Right.
But could you give a brief description of your view of what determinism entails? Because I think through your talk, I was able to get sort of an idea of what your conception of it is, but it laid down in concrete terms while I was here. So,
okay, that is great. Sure. So determinism is the idea that you can write down laws of nature that are more elaborate versions of Newton's second law of motion. F equals ma in the classic way of writing it, or as I presented on the slide, A, the change in state of motion of an object, equals the force applied divided by mass to make the units come out. And determinism says that law applied to one object says what's going to happen to that object forever into the future if only you know the forces between that object and every other object, and you know where everything is and how it's moving at a given time. And determinism extends that not only to one object at a time, but to every object that makes up the universe.
Right. So you mentioned the other aspects of physics that we've come across since Newton, things like chaos theory and how complex systems may be very sensitive to their initial conditions and thus tough to predict, even with best computers. Things like relativity being a more nuanced exploration of how gravity actually works in extreme circumstances, quantum mechanics, how there's an inherent randomness at the fundamental at that fundamental aspect of reality. So lots of things that aren't just Newton's laws. So would you say that uncovering the new ways that material things are influenced by forces and some such, would you say that is necessarily opposed to your view of determinism, since your view of determinism is based on just Newton? Or do you think determinism could still encompass like the new laws as in addition to the old?
Well, if it were only a matter of fixing the laws, in principle, the paradigm should still go through. But the fact is that it's neither computationally possible, nor does the material description of the world really do justice to how we feel it's put together.
Right. My first follow-up question would be, why does our inability to calculate, like I think you addressed this a bit in your talk, like saying that you could in principle figure it out if you had all of the necessary information, but why does our inability to actually predict everything to the minutest little detail, why does our lack of ability influence or determine how deterministic our universe is?
Okay. It's two things at least. It's the failure to have any kind of view that looks like it could possibly be complete and correct, but it's also the fact that no concept that I've ever even heard anyone conceive of in physics-like terms gives us the sense of participation, the sense of the flow of our consciousness, or of the truth of values like truth, beauty, goodness, justice, and so on. They seem to be as real as where that thing is, how fast it's moving, how strongly something is tugging on it. And
so be fair to say that I just want to make sure I'm understanding your position correctly. And correct me if I'm wrong if my rephrasing doesn't fully capture what you're saying. So our experiences of like what is just and moral and our desires, are, for lack of a better term, will, like that, those things, subjective experiences are feel real and thus cannot be determined by anything else?
Well, yeah, that's a way of saying it, but let me rephrase it in a way that sounds clearer to me. It may or may not sound clearer to you. That I have numerous times been really glad that I spent time talking to a student, helped a friend figure out some problem. I felt like I made a difference in the world. Okay. And I've built my understanding of my life on thinking that, sometimes what I do matters. And I don't know anyone who doesn't have that feeling at least some of the time. Of course, some of the time we're spinning wheels, okay? That's life. But what we do matters. And if what we do matters, then we have stepped outside the physics paradigm, and we shouldn't use that paradigm to check off all those things on the list that you're not supposed to believe in.
Right. Okay. So my follow-up question to that is, why does us having this feeling of purpose, of meaning, how does that step outside of the physics paradigm?
because it is a description of existence where goals aimed at a future state are the important things about how the world works, not the
Isn't
description
that
of the past.
of determinism is saying that our like past and present necessarily contribute to how the future is going to look? So goals
If you're a
with
determinist, if you're a determinist or a strict naturalist, then we are then the past and the present do exactly determine the future.
right. So wouldn't goals facilitate that?
Pardon?
Wouldn't us having goals facilitate determinism then? Because if
No,
we,
no. Determinism says goals don't matter
why not?
because they don't even fit in there. They are aspects of the future. They're not aspects of the past. Mark, I see
They
two hands formally raised, and
I'm at goal in the present,
Jacob,
that future.
I'd like to take other people's questions
Sorry.
if I could. All right, and Mark, do you have something that's procedural, or should I go to Mark Savid's? Mark Watkins, do you want to interrupt for a procedural reason, or are you raising a hand to raise a question? I can't hear you. If you.
I was going to raise a question.
Okay, so I will get to you after Mark Savid and Sam.
So,
Mark Savid, please.
so Peter, it's lovely to see you. I'm glad you're here. I did take physics in high school, luck, but I forgot everything. And I'm not going to about it. Do you think it's fate or good luck that you came across Marilyn Robinson?
I don't believe in fate. I do believe in chance. So if chance and luck are two words for the same thing, I feel lucky to have come across Marilyn Robinson. Is that a helpful answer to your question?
Yeah, that's just fine. Thank you.
Yeah.
That's it.
All right, Sam.
Hi, Peter. I'm not sure if this is a physics question, a religious question, or a nonsense question, but people who espouse intelligent design, which is sort of creationism plus, would you describe those people as naturalists?
No, and I think they would be insulted to be considered naturalists because, as I understand the ideas that go by the name of intelligent design, it specifically posits a supernatural influence not described by the laws of nature that makes all the difference in how the world comes out. So it's very much a goal-oriented system, except the goal is not yours or mine, it's the designers, and the designer is a coy name for God in that system.
But I thought you said that the strictest naturalists would not have a concept of God or the supernatural,
Right.
but that people who are less strict naturalists could. Did I get that wrong?
No, you got that right. So maybe repeat your question again. Maybe I misunderstood your question.
No, I think you got it. And I think you answered it. Thank you.
Okay, sure. All right, Mark Watkins.
You said that naturalism is astonishing. You just gave various properties of naturalism, but it's like telling us about it, but not what it is. And how would naturalism differ in its strictest form from determinism, or is naturalism part of a whole continuum?
Well, naturalism, as I understand how the word is applied by various people, is that very broad continuum that I tried to summarize on that one slide of different versions of naturalism. Strict naturalism, the idea up at the top that we're machines made out of atoms, get used to it, is the last refuge of a determinist after that determinist has been convinced that you can never actually carry out the determinist program. And a strict naturalist says, well, gee, I don't need to carry out the calculation. The most important thing for me is to know why I shouldn't believe in that list of things. God, the supernatural, the reality of values, free will, things like that. So strict naturalism is someone who says, you didn't impress me by saying determinism is too hard to actually do. I still believe in its fundamental tenets.
And what is nature when you use the word nature?
Ah, what a beautiful question. This is really the trickiest thing about having any kind of discussion about this. Everybody thinks they know what nature is, and there's no good definition of it that everyone agrees on. And that's why there can be so many different forms of naturalism. If you believe nature is the material world, full stop, likely you are a strict naturalist. But if nature is a term that for you just means whatever the hell exists, I'll call that that whatever the hell exists by a term nature, that's fine, but it doesn't commit you to the mechanical, purely mechanical view of the universe. Is that helpful, Mark?
Yeah, yes, it is. And one final question,
Sure.
just to be perverse and defend determinism, which I don't believe, but the various laws of physics and other sciences predict things, maybe not perfectly.
Mm-hmm.
Does the determinist have to have everything predicted exactly? Or could we have small errors like that would be created because we're using Euclidean geometry instead of hyperbolic geometry or something like that?
Mm-hmm. Well, I think if the word determinism is in play, you don't want to say, oh, it's almost determined, but there's small errors, because then are those errors or are those things that are coming from outside the deterministic paradigm? So, but let's put aside determinism. I think determinism as a program is dead. But if you meant to ask me, can you hold to strict naturalism even though you don't see how you can do the calculation precisely? Of course you can, but in so doing, you are giving up in advance. I think what it means to say I'm a strict naturalist is, no, I don't believe that goals matter. I don't believe that values are real, and I don't believe that any choices make a difference, because I believe the world acts as if it's a machine in principle. I just know it's too hard to do. So that's the the thrust of an attachment to the idea of strict naturalism. I think that's what it means. Is that enough appealing to you?
Considering the laws that we have, that's the best we can do, isn't it?
Well, it is the best we can do if we're committed to a paradigm that says, well, the laws really would explain it if only we had them perfectly. Okay, I just don't think we can. But it's something for each of us to figure out.
I don't want to take any more time.
Okay. Rabbi Steinitz.
Thank you. First of all, thank you so much for giving us the pleasure of this talk. It's really wonderful to meet you and again, and looking forward to seeing you in person. You talk a lot about Heschel, and for very, very good reasons. But in my mind, the probably the best example of this soft naturalism that you're describing is Mordechai Kaplan.
Go on.
Yeah, any thoughts about his thought?
Well,
I know he just doesn't really write as beautifully as Heschel, and
yes.
it doesn't have the nice quotes, but
Yeah. No, that's a wonderful point. And let's between us share with the other people on the call why your question is such a good one. There, Mordecai Kaplan and Abraham Joshua Heschel were both leading lights at Jewish Theological Seminary for overlapping several decades. Kaplan was something of Heschel's senior, if I'm remembering dates right. And most, the sort of this oversimplified version of the history of 20th century Jewish theology is that Heschel and Kaplan were saying things that were completely at odds with each other. And I've read that summary of things many times, and I've come to believe that it's completely wrong, and that what you just said is much truer, that Kaplan was a soft naturalist, an expanded naturalist, or whatever adjective you want to add. He insisted he was a naturalist. And that's why people put him in opposition to Heschel. But if you actually read his description of what he understood his naturalism to mean, he definitely believed that people's choices mattered, that values were important, that there was some kind of meaning to the word God that was not just an elevator word. And he meant all these things that stricter naturalists would find anathema. And so I actually think what you said is 100% correct. He wrote much less beautifully than Heschel. It's clumsy, it's clunky. He keeps pretending, or feels like when I read him now, like he wants to pretend that I am a naturalist, so don't think I'm not being scientific. But when you get under the hood and you read carefully, he's saying something very similar to Heschel, that the naturalist paradigm in its strict form is anathema to him, just as it was to Heschel. So thank you for bringing that up. Maybe if I keep at this long enough, I'll end up calling myself a Kaplanian, but I think I would have to work even harder, because, as you say, he's even harder to parse out his true thinking about these things than it is in Heschel.
no, absolutely.
Yeah. Okay. So thanks for that. So
Thank
Paul and/or Chris, please unmute and ask your question.
So my question is, we're talking about elements, and I think there's a term inanimate and versus animate objects. And so when we talk about physics, I think, and I may miss something in the entanglement, maybe there's a randomness to that, or a thought process to that. But for a human being, if you talk about a rock, okay, or a projectile, you throw a projectile, you force it out a certain force, it has a certain weight, it's going to accelerate at a certain speed, and that's more or less a law. That's what's going to happen. But for a human being thinking, we're the ones that decide if we're going to throw that rock.
Right.
You may or may not throw that rock, and so two people. So one of the things I see today is two people look at the same data. One person says, gee, this agrees with what I already believe, so I believe it. And then the other person thinks, I wonder if this is true. So is there a way? So that's something a rock doesn't do. The rock doesn't say, I wonder if this guy threw me. So is there a difference in this concept based on whether something is alive and capable of thinking versus inanimate rock that just happens to flow with the force of nature?
Yeah. Well, thank you very much for that question. One way I could interpret what you're saying is that you've formulated exactly what the challenge is. Do the laws of nature that we have checked and work extremely well for simple things like rocks also apply, or at least apply in principle, to things such as us, which are potentially treatable just as very complicated objects. Or, on the other hand, it could be that it's not just the complication of us, the huge numbers in our brains, but the fact that we are capable of goal-oriented action and not action determined by the state of the universe in the past. So it's very much, you've summarized beautifully what the issue is. Thank you. Bob or Julie, hi to both of you.
Hi, nice to see you.
Nice to see you too.
Excited that you're going to be here soon.
Nice, yeah.
So I never had a physics professor that presented what you presented.
Okay.
As a professor, did you struggle with being a little schizophrenic, with being able to present your thoughts in a physics class at SU or elsewhere? I mean, how do you as a physics professor live in, I don't know, is it two worlds or is it merged?
That's a wonderful personal question, but it's a fair question, and so I'm very glad that you raised it, Bob. Nobody wants to have two different minds that they switch between depending on the situation, and that's because you only have one life, right? And you only get to make a few big choices, and then work hard all the time to live up to those goals according to your values. So that's the ideal, and it's much easier for me as a retired emeritus professor of physics than one showing up at work every day with other physicists to talk this way. So now I'm making a sociological statement. It's not just a personal statement that as I think back to my various colleagues at SU and elsewhere, there are a number of them who would have thought that a talk like this was disgraceful and betraying the cause and letting down the side and helping the wrong people win. Not everyone, okay? I have very good, well, I was about to say friends plural, but one very good friend in the Syracuse physics department who was more committed to this way of thinking and living than I was, okay? But he and I together were kind of outliers from the rest of the world in which we live. Now that's a sociological observation. The bearing it has on whether one idea is true or not is, only coincidental perhaps, but it did make for some uncomfortable moments for me, not because anyone was mean to me or caused me a problem, but since I realized that my way of looking at the world was pretty strongly opposed to most of my colleagues, that's a disturbing thing, even if no one is being mean to you or causing you a problem. So don't know what to do with it other than to say now that I'm no longer actively doing physics research in the context of a physics department at a university, and have chosen to push my thinking in this direction. It's easier to do. I see a hand from Mark Eisenbees. Mark, you disappeared just a moment ago. Please ask. Yes, hi. Can't hear you yet.
Mark, you're still muted.
You're on mute.
I have to find the buttons.
There you go. You got it now.
So I put a few observations in the chat that I wanted you to maybe respond to.
Please do.
One, I really think that determinism's fatal flaw is that we are part of the system that we can't observe fully, in either an extent or scale or time. Done. We're kind of done there. Like, I don't know if I have to spend any more time on that. I'm not sure if you've made, and I'll just say I'm an ecologist. My background is ecology. So I'm sort of forced into this naturalist viewpoint to a large degree. I really think, I don't know what your perception of this is, that there may be a certain vanity that we as humans, and being part of nature and the limits of our own biology, are capable, and even as you outlined in the determinism, that we're capable of even comprehending nature because of our limits in perception. And so, and I'm not sure that you've really made a case yet that the human traits that you outline that are clearly, like, noble things, aren't just simply evolutionary advantage. And then sort of my back out of this is that I was reading about these philosophical backgrounds about the naturalism, and I'm not even sure if I agree with naturalism's definition of itself, because it says that it stands in opposition of the supernatural, and I am really not sure. I'm also an agnostic, and I'm not sure if natural and supernatural are opposites, and not instead just they're orthogonal to each other. So I just was wondering if you'd think about that.
Yeah. So it's an excellent question to raise, and the idea that we have the traits that we have as a result of them having developed over the course of time through the process of evolution, I see no reason to disagree with that. But I don't know then how that disposes of having the traits. That if I have the ability to think about my situation and make a choice, I don't really think that any less of the powers that I've developed because they arose through the process of evolution. So to me, how these powers came into the world, it's a very interesting scientific question, don't get me wrong, but the fact that they arose because of evolution doesn't make them any less wonderful. And I hope this doesn't seem like a snarky response to your excellent question, but let me ask you this. Thank God ecologists are around and warning us about, how delicate the ecosystem is and how much in danger it is. I don't know you yet, I'm sorry to say, but I haven't met any ecologist who wouldn't at some point or another say, the world is in desperate danger. We need to, respect nature and not keep banging on it. And, if we keep burning fossil fuels, whatever is the worry of the moment, and that's a real one as far as I'm concerned, we're in danger of wrecking everything. Anyone who utters that sentence has stepped outside the naturalist paradigm, as I understand it, at least the strict naturalist paradigm, and is making a values-based statement and is urging people to make free choices that they might not otherwise make in order to achieve a good future state and avoid a bad one.
I could make that same statement, though, completely emotionless. If we don't shape up, we're going to kill the earth. And say that without emotion and without any value judgment at all. We'll just be gone. And that's just a fact.
All right.
That's just factual.
Yes.
I have no emotion in that at all. And the evolutionary benefit of saying so is that we prolong the species.
Yeah. And so you think you get no juice out of saying that factual statement, and you don't care whether other people accept it? I
accept that people will or will not accept. I have no control over how people receive the message.
Yeah.
Right.
All right. You are the most dispassionate person alive, and
no, I'm not. I'm very passionate. Melody will tell you, but I'm making the case I'm making the case that it can be made passionately or dispassionately.
Of course, of course. But I guess my claim is that whether you say you care or not about it, most people do, and that caring is an essential part of what happens to the future.
Yeah, you and I care. I can point to many people who don't care.
No, of course. No. But if the world contains people who care and who discuss this with each other and whose discussions make a difference, and that they care whether those discussions make a difference, that is, you've stepped outside the naturalist paradigm, as I understand it.
I guess I'm not really, I'm not going to adopt the paradigm. I only know myself. I don't really invest in these philosophies at all. I'm just saying that you're just speaking about the evolution of the species and perpetuating the species.
Mm-hmm.
That would be the case. But I also do not, I'm very honest that I consider the natural and the supernatural to be orthogonal. They're not opposites. There's no friction between those two things in my mind. They're not opposites.
Mm-hmm. Okay. No, I surely don't think they're opposites either, but neither do I think that they're orthogonal. But we can maybe pick that up later. Jared, you've got your hand up.
Peter, thank you so much. What a pleasure. It's so nice to see you. Look forward to seeing you in person again.
Of course.
So in college, I was a chemistry major, and
Mm-hmm.
I was 2 classes short of minoring in philosophy.
Mm-hmm.
I did a lot of this kind of thinking, geeky kind of thinking scientifically that I just love the way you presented. And I had a similar disconnection, if you will, from the faith after bar mitzvah, and then found a purpose again when I got to medical school.
Mm-hmm.
And it was an anatomy class that made me fully appreciate there is a God, and there is something more to be deeply understood. When you describe the determinism and naturalism, I couldn't help but think about our Western culture of medicine itself,
Mm-hmm.
where we've evolved very scientifically to do our best efforts to explain physiology and, if you will, the human existence to the scientific degree to an exhaustive extent. And what we're seeing today is more and more people are looking for answers or treatments or hope that's more naturalism, more Eastern medicine, more complementary medicine.
Mm-hmm.
And I'm not to say that one is right or one is wrong. There's a lot to benefit from each camp, if you will. But it strikes me so that physiology, or Newton's law put to medicine internally, that if this happens to a human being, this is going to be the outcome. And how many people have we known or experienced personally who have been diagnosed with a condition that has no traditional treatment, that there is an eventual termination to the existence, and they live forever, unpredicted?
Mm-hmm.
The determinist physician would say, the person would blankly say, "Doc, how many months do I have?" And the determinist doctor is going to go, calculated AF divided by M. Yeah, you got 2 months.
Mm-hmm.
But something godly enables their mind to overcome that determination.
Mm-hmm.
It's phenomenal. Free will and will is incredibly powerful when the mind itself can not only say, am I going to throw this rock, but it has as much influence on how I'm going to survive, how I'm going to live. And we see it so often. Somebody passes away, and a good close friend or a spouse. That is not predictable. That is not deterministic.
Yeah.
It is it's deeper. So I just wanted to reflect
yeah, I mean,
what I took away from some of what you've shared tonight.
Sure, and you would know this, these medical cases much better than I, but I appreciate very much you bringing them forward, because they point out that, you know, in things that we care about, like the length of time we are able to live beyond the diagnosis of an illness, or that a loved one does, that something at the mental / spiritual / free will level makes a difference. So I appreciate that a lot. I see Melissa, who wants to help us with this time we're spending together. Go ahead, Melissa.
So I just wanted to, out of respect for everybody's time,
Yes.
We're over what was our scheduled time. So I just want to say that I think we should wrap up the program and give you one last opportunity to leave us with your concluding thoughts. Then I know Mark has a very fast announcement.
Yes.
And then I'll close the formal program and stop the recording.
Thanks, Melissa. I don't have anything other to say other than I think people will want to hear what Mark Watkins has to say. And if anyone wants to get in touch with me to continue the discussion after the formal program, get in touch with Melissa and she can share my email address with you. I'm looking at Jacob, who is very patient but wants to say more. We can do it offline. Be happy to continue that discussion. But Mark, why don't you make your announcement?
I think there's so many points you brought up that could bear further discussion. The fact that we run this late is proof of that. I had thought that we would be sort of in academic speak inclined to have a recitation section. That is a time maybe 2 weeks from now where we will discuss these points, and I would hope from you to get a couple of discussion points that we could use to start a discussion online, and a time that we could do this just came up last night at the Board of Trustees meeting afterwards. That we go for 2 weeks from tonight. Those people who are here tonight might very well be able to come for another Thursday. That's the 25th, I believe. And you could store up your questions, and I think the slides are available online. Are they? So people could review them, and
they can be if I email them to Melissa and she knows a place to put them.
Are they the same ones you've sent me?
I've made a few small corrections to them, so I'll send cleaned up ones.
All right. Good. Then anybody who wants to can have a look at them and say, well, I want to say this or that, and this is their opportunity to do so. Thank you so much.
Okay, and thank you, Mark, for volunteering to run those sessions. And anyone who's interested, look for the email that will remind you of when it happens and give you contact information. And I will surely make the slides available. So I want to thank everyone for your attention, for sticking with it this long, and for asking such great questions. And look forward to picking up the discussion in future meetings. So thank you all.
ASL, thank you to Peter.
Thank you all.